Okay, we're going to get started with our mineral notes here. We're going to use a flow chart that looks like this. You should have this in front of you. You'll notice that we have it divided by section here. Today we're going to cover 9.1 here and here, and we will also cover 9.3 in the top right hand corner. So we've numbered things, so I'll try my best to give you which number we're at, but these are like the big ideas, so the 5 characteristics of a mineral. And in the boxes, you should then put what each of those are. Same thing over here. This would be a way that a mineral is formed, and this is where you're going to tell me about that. All right, here we go. So we're going to begin with the 5 things that make a mineral a mineral. A mineral must have all 5 of these in order to be considered a mineral. If it's missing even one, then we would classify it as a rock. Okay, the first one is that it needs to occur in nature. That means it cannot be man-made or have any sort of human interaction. Otherwise, that would not be a mineral. So it has to occur naturally. The second one is that it has to be inorganic. Now, inorganic does not mean dead. Dead material, dead once living material is considered organic. So when a tree falls down in the woods and it decays, that is still considered organic material. Okay, so inorganic truly means not made from living things, never living things. Okay, the third thing is, so number 3 on your flow chart, it has to have a definite chemical composition. So this would be the recipe. This is what it's made of. These are the elements or the chemical compounds. You know, a compound is 2 or more elements combined together. And it has to have the same recipe every single time. So this, what we're looking at here, is called halite. We would call it, of course, salt, which has sodium and chlorine atoms in it. The fourth thing is that it must be a solid. So this is how it would occur naturally. Obviously, we know if we heat or cool things, we can change them into different states of matter, solid, liquid, or gas. But a mineral must occur naturally as a solid. The fifth and final thing a mineral must have is a crystal structure. Okay, so this would be how the atoms are arranged. Typically, they're always going to be arranged in the same pattern over and over and over again. So that would mean if 2 different minerals were made from the same elements, what would make those minerals different is the way their crystal structures were built. Okay, so here are some different examples of crystals. We'll look at some of these in our mineral labs. You can see different things like cubes and hexagons and orthorhombic, which of course if you hear ortho, you should think 8 sides. And monoclinic is more like a sheet of paper, actually. All right, groups of minerals, different groups of minerals. You should now be in the bottom right-hand corner of the flow chart. So if you do not have this entire area filled in, you should go back in the video and find the areas you missed. We are now down here in the bottom right-hand corner. Okay, the first mineral group is the silicates. This is the most common group that makes up by far and away the largest amount of minerals. There are over 1,000 minerals in this group alone. These elements are made of 1 silicon atom and 4 oxygen atoms. And they account for about 90% of the Earth's crust. Again, over 1,000 minerals make up the silicates. And this is a little bit of what their structure looks like when we put those atoms together, and the different chains and different sorts of crystal structures that those can make. And here's a common example, which is called feldspar. And a feldspar is in the rock granite. Another common mineral, silicate mineral in our area is quartz. Okay, the next one is native elements. Simply native elements are on the periodic table. So gold, silver, diamond, sulfur, they contain 1 single element, not a compound, which again is 2 or more elements that are combined together. The third group is the carbonates. Carbonates contain 1 carbon atom and 3 oxygen atoms, plus either calcium, iron, or copper. Okay. Most carbonates are formed on the ocean floor. Okay. Now that's probably like calcites here. Always forms on the bottom of an ocean or a large lake bed. The next one is the halides. Halides, you can think salt. Okay, if you see anything like halite or halides, you should think salt. Okay, so a halide then is going to form, and this is how salt forms. It forms through evaporation, which we will get to a little bit later. These are going to contain sodium, chlorine, like I just mentioned with salt, fluorine, bromine, iodine, things that make up table salt, and fluorite. Of course, fluorite is used in toothpaste. And here's a picture of halite. Remember, salt crystals, salt grains are always in the shape of a square. Okay, the next group is the oxide group. Oxides, of course, contain oxygen plus 1 or 2 metals, like iron, for example. Okay, so the oxides are going to form things like magnetite, which you can see the little magnet attached to the mineral there of magnetite. There's also another one called hematite, and both of these types of minerals are very useful because they are iron ores, which we can then turn into steel. Okay, phosphates, very rare group here. It's again a silicon-oxygen base with the addition of phosphorus or arsenic or vanadium. These minerals are quite rare, which of course makes them a little more valuable. And this is probably the most common phosphate, which is turquoise. The sulfate group is a sulfur-based group, sulfur plus oxygen. This is another group that forms through evaporation. And the most common one here is gypsum. So again, if it's formed through evaporation, that means it had to have started with a water-based solution. Okay, our next group is the sulfides group, which is another one that contains sulfur. Now with the sulfides group, we have removed oxygen. So with the sulfates, it was sulfur plus oxygen, but with the sulfides, it is simply sulfur plus another metal element. So in this case, you see pyrite, which we of course call fool's gold. So this is sulfur plus metal, and again, this is an iron ore. So there is a use for these minerals. Use for pyrites is, of course, it can be turned into iron. Okay, you should, if we go back to our chart, you should now be done with all of the 9.1 areas. This entire area here and this entire area here. That leaves the 9.3 materials, which we will cover now. So how do minerals form? How do they get their structures? Okay, so there's 2 ways that a mineral will form. Number 1 is that they form from magma or lava. Okay, so molten rock. So for number 1, if you put molten rock, that would be great. If you put magma or lava, that is fine as well. Now, there's a difference here. If a mineral forms from magma, that means it cools slowly underground in the Earth's crust. Therefore, the crystals have a much longer time to form, and we get large crystals. This is very important that you remember this concept, that if it cools from magma in the ground, we get large crystals. These are large crystals. If we can see them with the naked eye, without the use of a magnifying lens, we call that a large crystal. Now you may need to add a little space here in your notes or put it up above. If it forms from lava, which means now the molten rock is above the Earth's surface, on the ground or above the ground, it's going to cool much more rapidly, and we will get small crystals. So the difference is, if it cools beneath the Earth, we call it magma. It has longer to form, we call it a large crystal. if it cools from lava above the Earth's surface, it will cool much quicker, and we will get small crystals where we would need a magnifying lens to see them. So the one way a mineral forms is from molten rock, either magma or lava. The other way is from a solution. A solution is, of course, water mixed in with dissolved minerals. It doesn't always have to be water. It can be other liquids, but for the most part, it tends to be a water-based solution. So you have water with a dissolved mineral. Now, if it's a dissolved mineral, that means you're not going to be able to see it. So obviously, you can't see the minerals that are in the water that you drink. If you go to the water fountain and you fill up a glass of water and you look at it, it just looks clear. Okay, if we were to let the water evaporate, it would leave behind the solid material, the mineral that is in the water that you're drinking. Okay, so here, this is again the way salt is formed. In the winter, when your parents drive in and out of the garage, or they park on the driveway and their car is wet, and they've been driving up and down the highway, which has been covered with road salt, when the car drips, it deposits a solution on the floor, which is water plus the road salt. Eventually, the water will evaporate, leaving behind only the road salt, which is why typically you see the garage floor or your driveway turn white over the winter, because your garage is literally being covered in salt. Okay, so one way is from a solution through evaporation. The other one is through what is called saturation. Okay, so just like with molten rock, where it can form either from magma or lava, for number 2 on your flow chart, you should have solution. And again, there are 2 ways it can form from a solution, either evaporation or saturation. Now with saturation, what that means is that the water is full. It is holding 100% of its capacity. It cannot hold any more. So think about like a cave. If you've ever been in a cave before and you've seen stalactites and stalagmites and you see dripping water, that water is saturated with minerals. So it is literally depositing the mineral content out of the water because it is just so full of mineral. So it literally deposits it. It doesn't need to evaporate. It just deposits it as it drips. Okay? All right. So your different formations are, number 1, molten rock, magma/lava, and number 2, a solution that is either going to form through evaporation or saturation. Okay, so you should have your flow chart filled out. Okay? You should have molten rock up in this area, magma, lava. You should have solution over here, evaporation, evaporation or saturation up here. You should have your 8 mineral groups listed here with an item or 2. I gave you a couple of things for each of those. And up here you should have your 5 properties, right? You should have naturally occurring, inorganic, definite chemical composition. You should have solid here, and you should have crystal structure here. And again, you should have things written about those there. You can always replay the video or go back and watch certain sections over. Leave this area blank for now. We will cover this area in the next video.